Somewhere along the path of building a video game, you will likely come across a problem familiar to other game designers. How exactly do I program this door logic? Today I will cover in depth the 3D design of a door model, as well as placing the door into a Panda3D game and animating it for use on a button press. The door design problem can be broken into 5 sections: 3D modeling, positioning, collision modeling, animation scripting, and finally adding some extra features like audio. The door construction is actually not that hard. As you can see, the 3D modeling is progressing in under half an hour to build the base model of the door. We've already gotten through modeling the basic rectangle, the handle, a little cylinder for the door handle where it's going to turn down, and the jamb, which is part of the door sill. We'll finish the jamb by selecting all of its polygons and moving it up to the center line of the door handle. Go ahead and spin around the model and add some more detail features. And at this point, the door is just about done, and we can go ahead and finalize the UV mapping and texturing. So it's actually very important to think about how your door is going to rotate inside of your game world. The actual position of the various objects inside the model file will have an impact on how the door is actually represented in the scene graph. So we can see from the top view that this door, if left this way when we export the model file, will rotate around its middle. And this is, of course, not the behavior we want to see from the door. So we'll go ahead and move it over to the part of the door where it actually rotates on its hinges, because that's the point where we'll define our rotation values for the door itself, the door handle, and any other extras. Now that our door geometry is set up, we can go ahead and start reviewing the logical format for getting this door to open and close in a game-safe manner. And what I mean by game-safe is in a way that you can press with a button, the E key in this case, without allowing the player to destroy your function by pressing the button too many times. And that is actually a harder problem than it might seem at first glance. So that looks an awfully lot like our door model. And as we can see in our physics debugger, there is a collision mesh around it. And look, it even works pretty well when we open and close it. We cannot go through the door, and if we open it while we're close, it pushes our character to the side. Pretty neat. I'll try not to forget anything too important as I go through each line of this door opening and closing program. We begin with loading in the door model that we designed in Blender. We're going to use this special Panda3D function to find one of the objects inside of that Blender file. And this is actually really neat because we're just using a Pythonic way of searching around in the graph of that file. And we're finding this thing called door, and it is actually called door in Blender. And you can see the handle, the jamb, and the so-called scrolls on the side. And we can actually access each part of that model in this manner in order to hide different parts of it, in order to set different parts of it up for animation. So this is going to get fairly complicated, but just bear with me. We're going to go ahead and hide the door jamb on this first. And the reason for that is it's just easier to make a separate model with just the door jamb. and use that as the static geometry because everything else is moving on the door. We're going to go ahead and locate the door handle as well. And then we're going to do our first special location command, which is to get the HPR of that door handle. We'll go ahead and reparent the model to self.render. We'll set the model scale to 1, which does nothing. We'll set the position at this location. And then we're going to, like I said, load in our dedicated door jamb mesh. And then we're going to start our collision geometry for the door. And so it should be said that Panda3D doesn't automatically generate collision boundaries just because you brought in some model file. So you'll be able to walk right through a model file that you'll just load in and set in this way. So we've got to go ahead and get into our physics engine and get a box shape. We're going to need a node to put that box shape in, which is called a rigid body node. Now we're going to go ahead and instantiate that object with this specific size. And this may look random, but this is just guess and checking. So what you do, or what I do, is I load the Panda3D program, view it in the window, adjust based upon my intuition about XYZ, and then keep checking until it's close enough. And I think that's pretty standard for designing this sort of thing. Our node is rigid body node. We'll go ahead and give that a label. We'll add the shape, which we instantiated here. The friction is literally just the friction of the simulated friction between bodies on the bullet world. Our door box node we'll go ahead and attach to self.render. Our door position we'll just call D position, and then we'll actually get an adjusted D position, which is again guess and checking, in order to adjust the position of our physics box to our translated door. Because as you remember, we put the door at the corner, or put the corner at the 0, 0, 0, so that we could more easily roll it or rotate it along this line. Now that we have that position, we'll put the door box node there. We'll attach the rigid body to the bullet world, and then we'll go ahead and get the door box HPR right now, because that's going to be useful for when we want to reset the position. The direct object here is what we're using to accept a function on key press, and this is actually a really handy part of Panda3D. The toggle door function itself is relying upon two different HPR value statements. So we're going to find the HPR of the door we're going to rotate and then do something based upon where it is right now. And that by itself is a good start, but it won't get you all the way there to a game safe function. So we'll go ahead and rotate the door outward using our lerp function logic. And I shouldn't say lerp function. That's actually a special type of lerp interval that is very handy on its own. But this is just a lerp HPR interval, which does nothing when you call it by itself. So we're going to have to get into sequences in parallels, or in this case, a parallel put into a sequence. We'll call the rotation by putting it on these lists. Parallels and sequences can be appended with these lerp intervals. And that's just what we'll do. And the specifics of each one of these inline declarations is fairly confusing to look at, I imagine, if you don't know exactly what all that means. But we're essentially just getting list comprehensions of the positions of these various objects. and then logically we're having the door rotate as its collision mesh rotates and as the handle goes down. Because these are in a parallel, they will execute simultaneously on the scene graph. The rotation, the collision rotation, and the handle going down a little will each execute at the same time once that parallel is appended to this sequence. And then we're going to have the handle coming back up animation appended after that parallel plays. And there are ways that we could have the handle animation go down and then come back up all in the same parallel. However, I thought for the sake of example, this was a little bit cleaner and it illustrates a parallel and a sequence quite interestingly. So we'll go ahead and go to the second part of the function. And this is basically a carbon copy of the first part of the function, just that the positions of everything are set to their original values. And at the end, we have the sequence begin, and we do that for both functions, calling that to start right at the end of the declarations. And that wholly defines our opening and closing function, except for that fifth extra features category that I mentioned earlier. You can imagine that it might be pretty easy to, let's say, record a sound of a door opening and closing, and then script that to play a sound when your simulated door opens or closes. And indeed, you can. However, I'll leave that for another time.